Hey everybody, welcome to Danger Person Code. Today we're going to be tackling the max subarray problem. You've probably seen this on Leak Code or Code Wars, or maybe in one of your classes, and you're curious about the solution. So basically, what this problem is you're given some large string of numbers, integers that could be positive or negative, something that looks something like this down here, designated nums. And then you're asked to write an algorithm that adds up the different subarrays within this larger array. It basically sums different chunks of this array at different positions and returns the largest sum that is possible by adding up a particular subarray within this larger array, right? And I think a natural inclination is to kind of just think that maybe just adding up the entire thing would lead to the largest number, the largest sum. But that's really not that's not the case once we start to throw in negative numbers, right? And also, I think a natural instinct as far as tackling this, and there's a couple ways to do this, is to just brute force it. Some people like to use embedded loops for this sort of thing. I recommend against that, right? Where you would just iterate through the list, and then at every position you iterate again through the list, and you just evaluate every single combination of possible values. While this might get you the answer, it will also get you that dreaded exponential n squared big O time complexity. So if we want to have a more efficient time complexity, especially if you're training for interviews, we're going to use an algorithm referred to as Kadane's algorithm. And this will produce a big O of n, big O of n, because we are going to iterate through this list only once. Okay, and we'll see how this is done. Okay, so let's get into it. So the first thing that I'm going to do with Kadane's algorithm is I'm going to define two different variables. One is going to be called current max. I'm going to set that to the zero index of our array. Okay. And the next one is going to be called global max. And I will also initially set that to the zero index of our array. And basically what these are is these are things that will allow us to keep track of a running total and the largest total that we've found thus far. So current max will basically represent the sum of the array that precedes the current position that we are at. And then global max will be the largest subarray that we have found so far. And then we will eventually return global max, right? Hopefully that is the largest array, right? That exists the in the list, right? When our loop is over. So we'll start out with both of these set to the zero index, and then we will create a for loop. So we're going to say for num in. So I'm actually going to slice this because the zero index of R is already accounted for. So I'm actually going to start out at the number one index. Okay. And for those of you unfamiliar with this, this is standard slicing syntax in Python. So we basically just start out at whatever index we want, right to the left of this colon, and then we go to some other index, non-inclusive. So if we put a number here, it will go right up to that index, right? But would not include it. If we leave it blank, it just goes straight through to the end of the list. Okay. So for each iteration of this list, we're going to do essentially two things. We are going to assign current max a new value. Okay. And we're going to assign global max a new value. So let's start with what current max is going to be. Current max is going to be whichever is larger between two values. And for that, we're going to use the built-in max function in Python. And again, if you're unfamiliar with this, this is basically just a built-in function that compares two values and returns whichever one is larger. So we want current max to keep getting larger as we move through the list. We don't want it to get smaller. And so for every number that we're on, right, for a particular iteration, we are going to compare that number to the whatever the current max currently is, right, plus that number. Whichever one is larger, that's what current max will become for each iteration of the list. And then we're going to do something similar for global max. For global max, we will compare global max to whatever current max has just recently become. Like I said, we want global max to be the largest that it can possibly be by the time we get to the final index of the list and we finish running the algorithm. Okay. So at the end of this, we're basically just going to return global max. And that is essentially Kadane's algorithm. It's really not very complicated. It's not very long, and it will give you a O of n time complexity, worst case time complexity. So if we did our work properly, the largest subarray that should exist within this list of integers should be 58. So let's go down here and we will print out the result of max subarray called on nums. And let's run this. Oop, my mistake. And there it is. Okay, 58. So this is Kadane's algorithm. This is the most efficient and therefore the correct way to solve the max subarray problem that you may have encountered on LeetCode. All right, great. Thanks for watching, and join me for more brutal savage algorithms.